Okay guys, as you can see, I have some spoiled laptop batteries. Here they are. So you might be wondering what I want to make with them. Of late I've been buying my batteries for my motorcycle, and within a month they get spoiled. Like some start swelling, some even they don't start the bike for like 2-3 times. So I thought of lithium batteries, and first I'm going to dismantle them like this, then measure their capacities as I write them on top, then use a BMS and make a good battery for my motorcycle. And I'll make a higher AH than the normal one. The normal one is 7 AH. Maybe I can make 10 or 14 double. I want to see how it will be like. So join me and let's dismantle this. So for doing all the dirty work, so now I've got some flat cells. I think for this I cannot use them in my motorbike, but I can use them in some IoT projects. You see these ones, yeah, mini, all this. Maybe I can use them in powering some of the upcoming IoT projects. I have many projects in place for you guys. I think for my IoT projects I will be sorted. Yeah, some are damaged, like this one are swollen. I have to throw them away. Then now these are the cells that I'll be using to make the battery for the motorbike. So after dismantling them from their casings, which are these plastics, so now what you get is this. Yeah, so okay, to remove them we'll use a side cutter. You just cut, let me show you. You cut carefully since lithium-ion are very hazardous. If you short them, they can cause fire anytime. You must be very careful. So in case of any damage to your property, please don't say I didn't put a disclaimer. It can cause fire if shorted. Yeah, so cut these strips to disassemble the BMS. You no longer need the BMS which comes with it, so disassemble. See, your cell should look like this. So after doing all that work, now I've got these cells which are now single cells. Yeah, and these are the flat ones which are single ones here, as you can see. Yeah, okay, so now take your multimeter, put it in DC measuring function, then take each battery and measure its voltage. Usually for me, if a battery is below 2 volts, I don't consider it as good. So measure all batteries. Okay, this is 1.7, just put it aside. Yeah, you measure all your batteries. Okay, after measuring all the cells, I was able to have around 19 of them, which were above 2 volts. These six were under 2 volts, 1.7 and 1.7 and 1.5 thereabout. I have resorted to using these ones, but I have some more if this one will not be enough to get the capacity I want. I want from 10 Ah and above for the motorcycle. Then to measure the capacity, we have this device here. I bought it from Amazon. Yeah, you see. To use it, you can use a USB-C, but since you are charging many cells, 1, 2, 3, 4 of them at once, you are measuring the capacity, charging and discharging them. Yeah, so I have this power supply 5 volt rated at 5 volt 10 amps. Yeah, so let me hook up and show you how this one works. So I put the power supply on AC, then on this side I have soldered a USB-C port. Yeah, then plug it in, and the power supply is on. So you hook up the capacity tester. Yeah, as you can see, it is on. So now you take your batteries. As you can see, there are polarities. There is the positive sides and the negative sides. Yeah, so this is the positive side of the battery, this is the negative side. You see the positive and the negative. So you hook it up like so. So you start with channel 1, channel 2, channel 3, channel 4. So this is the positive side, so you hook it up. As you can see, it shows is a 3.7 volt. You hook the next cell, 3.41. You hook up the next cell, yeah, 3.23, and the next cell, .117. Okay, so now on the settings below these buttons, there is one for the mode, another one for start or stop, then reset, then to change the channel. Maybe in channel 4 you want to see what is the voltage on channel 1. You press channel 1, 2, 3, 4. So on the mode auto, it has 3 modes. There is auto, on the modes is auto. Here you can see in red, auto, then charging, discharging. When in auto, it will charge the cell first to full, then discharge it one. Each cell is independent, so it will charge the cell to full, then discharge it, then charge it again to know the capacity. So guys, after measuring all the capacities of the batteries I had, so some were either became hot or their capacities were bad. Here are some of them. Like for this one, I had a capacity of 56. This one is not something you can put inside your motorbike battery because of the high current when starting. So
I got to measure the capacities as I write them. Yeah, I showed you what I was using. I was using this capacity tester, which can test 4 batteries at once, yeah, independently. Yeah. On the settings, I'll make a video on how to set it. Yeah, and yeah, so these are the capacities. You see, like for this is 1666 mAh, 2265. Yeah, like so. There are 24 of them. So let's go back to the computer. Let me show you how you arrange these batteries so that you can have one good pack with a small deviation, or one which can do a good job. So let's dive in. Okay, so let's now dive in to where you will set your cells. So you have already, I'm assuming now you have already written the capacities on them. Yeah, if it is 1000, you write 1000. If it is 200, like so. But when making this cell, please make sure the deviation is too small, because for me I chose the cells between 1600 mAh and maybe 2500 mAh, the ones those which are within that range. So you come to this website, which is called repack, like this, repack.com. Yeah, you type on your browser repack.com. Yeah, so then press enter. So here is where you'll have to key in all your cells, and then this website will arrange them for you, how you will make them in parallel and series. Yeah, so you see when it opens, you are here on home, so you come to packer. See what it tells you, comma separated list of cells in mAh to be added to the packs. So if you put the mAh of one cell, you separate with a comma to the mAh of the next cell. So let us do that. The first one is 1606, you separate with a comma. Next 1666, you separate with a comma. As you can see, these are my cells, these are the capacities. I've already keyed in all of them. So after keying in all of them like so that now you don't have cells which are places which are powerful than the others, so you use this repack.com. Yeah, then come here and click add cells. After clicking add cells, so how many cells do you want in series? Maybe you want to make a 3S battery, that is 12.6, maybe a 4S, that is 14.8, like so. So for me, I want this one to be a good one. I want it to be 4S, 4 cells in series. That one will make a total of 14.8 volts. Okay, so what's the number of cells that I want them in parallel? Because I have 24 cells, I just need 6 of them in parallel. So I'll have 4 in series and 6 in parallel. Yeah, so the nominal voltage of each cell is about 3.7 volt. That is for the 18650s. The nominal voltage is 3.7. Then after that, you just have to click here, generate packs. So let us click the generate packs and see what will. Yeah, this is how it should be. So the nominal voltage is of 14.8. Now the normal AH for my motorcycle is 7 AH, but for this one it will be having 11 Ah, yeah, and 169 watt hours, yeah. So it has generated the packs. How you will arrange them in parallel. So this is the first parallel pack, yeah, the second parallel pack, the third parallel pack, fourth parallel pack, you see pack 3, yeah, and if there are unused cells, they'll show here at the bottom, yeah. Let us go through this. So you see their capacities, these capacities, you will arrange them according to these capacities. See how they are. So for that, you will have your first pack, then you go to your next pack, go to your next pack, like so. So for this first pack, it will be having 11,493 mAh. The next one is 11,489 mAh. You see the deviation is not too much, it's about the deviation of 5 mAh from the other, yeah, 1 mAh from the other, 14 mAh from the other, 8 mAh from the other, yeah. So I think this one will work nice, yeah. At least each one is around 11,400 mAh, yeah. See. So now let us begin to arrange these cells from the first pack, second pack. Okay, so now after doing my cells on repack.com, as I've shown you on the computer, so now let's proceed to arrange our cells. So now here is where our 4S BMS comes in. Okay, this BMS you can get it on ensanelectronicslab.co.ke. Yeah, it is very cheap. Either you need a 3S, 4S or 5S. I've already shown you how to arrange your cells after you got your arrangements on repack.com. So here is our 4S BMS, as you can see it. I'll just get it through. There it is. These are 4S 100 amp BMS, yeah. So for my cells, because some are damaged on the on this sheath, I'll have to use these ones. You can also get this one on ensanelectronicslab.co.ke, yeah. So this is how you do. Let me show you either with one or two. So you take your hot air, this one, then take your cell, mark what you had marked before. Like for this is 2037. Okay, so put it in here, it will fit in well. You see. Then you see how it looks. Take your hot air, take your hot air, then burn through like so. You see how it is coming good, yeah, like that. And you have your good cell. Then now take this and write what you had written before, the capacity 2037. So let me proceed and do the rest. Before we proceed, please, if you enjoy my work and you would like to see more of this, please buy me a coffee, the link in the description below. Thank you, and let us proceed. Yeah, as I showed you earlier on repack.com, so after making my cells, I already printed these cell holders Yeah, as you can see here, there are others which have not yet removed from the printer. Yeah, here are a number of them. Then I joined them together. If you need these and you're in Kenya and you don't have a 3D printer, please contact me. Yeah, you just join them like so. This helps you put your cells in order. Yeah, they are called the 18650 cell holders. Okay, so after coming to the repack.com, you follow the parallel pack. The tools you are going to need to join your batteries is number one, these are I bought this from Amazon. It is a mini spot welder. Yeah, it's a nice one to make your things, your spot welds. I have used it before and it has not disappointed me. Yeah, so use this. It's charging actually by the way, but I'm using it as it is. Okay, so now following your cells will be of different capacities. So following the order you got from the repack.com, arrange them in series. These brackets I joined them in 1 2 3 4 in series, then 1 2 3 4 5 6 in parallel. So all these parallel packs, I'm going to be putting them in this six sides. Yeah, this side which has 6 cells, right? So let us begin with the first one, and before we go, you will interchange their polarity. If this side is positive, the other one will be negative, positive, negative, so that this side can be in series, this side is in parallel. I hope you get that. If you don't understand that, please Google series and parallel. So on my first cell, my first parallel pack, I'm going to take 2090, 2037 like so and arrange them. So let me proceed. Yeah, so you see, this is the negative side. I'll put it pointing down, put it, insert it like so. Yeah, then next is 2037. So arrange all this, and let's meet after arranging all of them. As you can see my pack now, I have arranged it as it is on the repack.com, how it arranged my cells. Yeah, so this is the series I was talking about. This side is series, so this is positive, negative, positive, negative. You go interchanging them. Yeah, so after doing all this, take your top cover. Yeah, then insert it. So yeah, that is my battery. You see how it looks. That is my battery. You see how it looks nice. Yeah, you see, and according to me, I think it's almost the same size as the normal one. So let us compare the normal one. Just a minute. Yeah, you see, it is almost the same size. Yeah, see, and the lengthwise, you see, the widthwise, it's almost the same size. and the widthwise here, and the lengthwise it's almost the same, as you can see. Yeah. So now the next thing is putting this BMS, but before you put the BMS, you must first solder your cell. Yeah, so let me show you how you do it. So I had started spot welding, so this is how you do on this small alcohol spot welder. You switch it on, there's a button behind here, you see. Then there is these two touch buttons. You set the power you want. The power goes up to 30, so let me set power 24. That is what I had tested with. Then because now this is a high current, you will join these nickel strips, these ones, you will join them. Then I've set my power 24. Yeah, and we begin working. Don't press too hard, it will still work. Yeah, like so, like so. Yeah, spot weld is looking fine. So now we proceed with the others. So it will be positive, then join negative to positive, negative to positive, then negative to positive, then you have your last negative here. Yeah, on these two centers I'll use a smaller nickel strips. This is what I had left, and I had no money to buy more, so I'll use what I had. But for the high current, you have to join these, at least 4 of them, at least 4 of them, to attain maybe 100 amps. Yeah. Okay, so let us proceed. Okay, so after making your battery like this, yeah, use Kapton tape. This tape is used because it is heat resistant. Kameramani, panda hapo, panda hapa uone, ndio kuja uone, panda hapo, weka kiti hapo upande, ndio. Haya, panda hapo sasa uone, nikwambia ufanye hivi ta, si ndio? Haya hapo. Haya, ngoja sasa nitakwambia, si ndio? Haya, niona kama hivyo. Haya, so after making your battery like this, then now it's time to solder the BMS. So now my BMS is well wired. So now you can structure these wires accordingly. So the output will be here and the positive side according to the diagram. So let us measure the voltages and see how it is. So here is my multimeter. Okay, so from our negative side, we start with first cell. Yeah, that is 4.1. This is how you are supposed to know that your BMS is fine. Then go to cell 2, 8.2, then cell 3, 12, then the last cell, which is 16.4. So according to how I did this battery, I made this soldering of this 2.5 millimeter wire, because the starting current of a motorbike is usually very high when you are using it. When you are starting the motorbike, the starting current is usually very high. So because my nickel strips were not enough, so now I decided to solder on the 2.5 mm wire on top of it, not on top of the cells. Yeah, I think I thought a bit because these cells can easily catch fire when you overdo the heating on them. It is not usually recommended that solder on them. So yeah, this is my battery casing. I'm printing it with my Reality High printer. If you haven't seen the review about the printer, please check the previous videos. Yeah, so this is how it will look like, and so far it is at 22%. And finally our model is done. Took 15 hours and 14 minutes. Used 486 grams of my filament on my Creality High printer. So let us remove the support material and see how it looks as we assemble the others. All the work, this is what I came up with: the battery, fully 3D printed case, and you can see how good it is. Yeah, shows the polarities and some electronics, the voltage, the amperage. Okay, it is 11 Ah, but on the making I wanted at least 10, so I just made it 10 Ah. Then it is a lithium-ion, yeah, as you can see. Then on the side too, yeah, printed that. I used, this is wood filament, PETG. I love PETG due to its durability, yeah. And if we measure the voltage here, we shall get 16 volts. So let me do that. Okay, so here is the positive, and the negative. Yeah, you see it is 16.32. yeah, so yeah, let us now move on to testing it on our motorbike. Let's see if it will start or not. Okay, let's start. Start. If you have reached this far of this video, thumbs up, and thank you for watching. Our project was a big success. I am overwhelmed with joy after seeing that our battery did all the functions the other battery was doing. And now on the previous video which I showed you about the display, the project is coming soon. So guys, let me see on the comment section what you think I'm making with the display, and let's meet